Hello guys, I hope you're doing well and I hope you enjoyed the previous two videos of prime number. This will be our last video for the prime number. Here I'll be dealing with two different ways of printing out prime number. So for the first way, I'll just enhancing the same code that we did last time. I've already created a file called prime3.php and I've copied the exactly same code that was on prime2 and pasted it here in prime3. So one more thing that we want to do is, let us suppose we try to see if 16 is a prime number. In case of 16, we know the multiple of 16 are 16 itself, which we don't want to check because that is valid for all of the numbers. The same number is always divided by the same number. And another multiple of 16, I mean the number that divides 16 is 8. Another number is 4 and another number is 2. So these are the three numbers that divides 16. And what we have done here is we have checked if half of this 16, which is here, see, we have divided 16 by 2. If I is odd, we have just added 1 to the I and divided by 2 just to get roughly to the half the way of the number. And if it is even, we have exactly calculated the half of the number and we have started our second loop from that position. So in case of 16, we'll be starting from our loop from 8, okay, and checking. And if we check if 16 is divisible by 8, and in that case, yes, 16 is divisible by 8 and flag is set to 1, and the loop decreases to 7, and we check 16 against 7, then the loop decreases to 6, then we check 16 with 6, the loop decreases to 5, so we check 16 by 5, and the loop decreases to 4, and we check 16 by 4, the flag is again set to 1, and so on. Let's say the loop reaches the value of j decreases to 2, then we check 16 by 2 and the flag is set to 1/3 time. But is that really necessary? If 16 is already divisible by 8, do we still need to check by 4 and 2? I don't think so. Even only one number that is not the number itself and 1, and any number is divisible by itself and 1, so we don't have to check for those. Any other number that is not itself or 1, and if that number divides any number, then that number is not prime number. Even if 16 was only divisible by 8, even in that case 16 would not have been prime number. So there is no need of checking 16 by all of these three numbers, because 16 is divisible by 8. That is sufficient to prove 16 is not prime number. So we don't have to loop through let's say 7, 6, 5, 4, 3, 2, 1, because we know 16 is divisible by 8, so we don't have to move further. Just like continue moves our code to the starting of the loop after decrementing the value, right? That means the command continue takes our code to the top of the loop after decreasing the value. Similarly, there is another command or another code that breaks the loop completely, which means the loop is no more executed, which means if we have found any one number that divides the given number I, then we don't have to check it with any extra numbers. So if I have found for any loop of I, if we found any value of j that divides the I, we can break the loop immediately by using command break. So this will break this loop, but not this loop. This loop still continues. Now the value of I, suppose we are checking against 6, then 6 is checked against 3, and it is divisible by 3, so it is no more checked by 2 because we have found a number that divides 6, that is 3. So it breaks the loop. So again the value of I reaches over here and it is increased from 6 to 7, and we check against 7. So this way I think we will be able to reduce number of loops more. Let's see this time how many loops do we run. prime 3. Now you can see the number of loops is only 933. In the first approach we had 4950 loops. In the second approach we had 2450 loops, and third approach we have only 993 loops, but the result is exactly the same. So we can see that we are getting better and better in codes. Okay, let us now try one last method of printing out prime numbers. And in this method, let me just create another file, prime4.php. And in this method, instead of using just the variables I and j and counter and flags, we'll be dealing with arrays. So I would like to create an array prime, okay, and I just want to set prime as empty array. So in order to make an empty array, we can just create like this or like this. Both the way is valid. So this we have created an array, empty array, where we'll be storing our prime numbers. Now what I want to do is, I would like to use the same loop, for loop, and start my loop from 2 and print from 2 to 100 I++. Okay, so what I want to do is, in the previous videos what we did, let me just copy this just to stay intact with our context. Okay, so in the first video we checked against all small numbers like this. In the second video we just went to the halfway like this. In third video what we'll be doing is, let me give you another definition of prime number now. So prime number is a number that is not divisible by any smaller prime numbers. Since we know from the first video we discussed that prime number is the building block of all the numbers. So any non-prime number is derived by the multiplication of 2 or more than 2 prime numbers. So if a number is divisible by other number, then for sure we can say that the number is divisible by other prime numbers. So for example, 6 is always, if 6 is not a prime number, then 6 is always divisible by the prime number that is less than it, at least one of the prime numbers that is less than it. For example, 2 and 3, both of these are prime numbers. So if 6 is not divisible by any of the prime number that is lesser than 6, then in that case 6 is also a prime number. So for example, but here we can see 6 is divisible by 2, 6 is divisible by 5, so 6 cannot be the prime number. But what about 5? So the prime number that is lesser than 5 are 2 and 3, but 5 is not divisible by 2, 5 is not divisible by 3, so 5 is also a prime number. So we got three prime numbers. Now let us just collect our prime numbers here. So 2, 3, 5. Let us check against let's say 7. So the prime numbers that are lesser than 7 are 2, 3 and 5, and we know that 7 is not divisible by 2, 7 is not divisible by 3, and 7 is not divisible by 5. So none of the prime numbers that is lesser than 7 divides 7. So in that case we can add one more prime number to our prime number set, that is 2, 3, 5, 7. Let us check against 8. We know 8 is divisible by 2, so 8 cannot be a prime number. So 9 is divisible by 3, so 9 is not a prime number. 10 is divisible by 2, which is a prime number, so 10 cannot be a prime number. But 11 is not divisible by 2, 3, 5 and 7. 2, 3, 5 and 7. That's why 11 is also a prime number. 2, 3, 5, 7, 11. So we have one more prime number in our set. So this proves that any number that is not divisible by the prime numbers that is lesser than that number, then that number is also a prime number. So these sets starting from 2, 3, 5, 7, 11, we'll be collecting these numbers in this array. And instead of checking from halfway, suppose we are checking for 100, then we have to loop from 50 till 2, which is 50 more loops. But instead of checking from 50 till 2, what we could have done was we could have checked if 100 is divisible by any of the smaller prime numbers. So we could have reduced our loops drastically by doing so. And again, since we know that we don't need to check for any number that is greater than the half of the number, so we can also check for only those prime numbers that is the halfway of the number. So for example, if we are checking against 2, first of all, if the box is empty, if the array is empty, we'll just add the number to the array. So what we will doing is, if there is no value in prime, that means array is empty, then we'll just simply add the number into the array. So since we know that prime is empty, in the first loop 2 is added to the prime. Else what we'll be doing is, for each value in prime, we'll be dividing the value of I with that number. So for each $prime as $p, what we'll be doing is we'll be dividing the value I with that prime. So if $I modulus p, which is the prime numbers inside prime arrays, since we are looping against prime, and in each loop we are assigning the value of prime to p, and we are checking that against I. So if I is divisible by p, then if I is divisible by p and the remainder is 0 in any one of the primes, then what we'll be doing, we'll be setting a flag to 1. So initially the flag is 0, let's say flag is 0. So we'll be setting the flag to 1, and we can just break the loop like we did before. We don't want, if any one of the prime divides I, that in that case that number cannot be prime, so we can directly break the loop. So this for each loop is then broken, and it moves against the for loop. And secondly, what we can do is, if prime, or let's say if the value p is greater than $I divided by 2, which means we just want to go to the halfway. We don't want to loop through each and every value of prime. So we just want to check against those prime numbers that is half of the number that we are about to check, that is I. Okay, so if the value of p is greater than 2, then we just want to straight break the loop, because we don't want to check for any prime number, any number that is, we don't want to divide to check I with any number that is bigger than itself or half of itself. So let's see if this prints out prime number. Okay, now what I want to do is, inside else we could also have stored so here after the for each loop, what I'm doing, if $I flag is equal to 0, this means we have found another prime number. So what we can do is we can push that prime number into the array prime, just like this. So we have found, if we find a new number, then we just push it to the prime number set. That's what we have done. So we have, initially we had empty prime number. In the first loop, 2 gets inside the prime number, and in the remaining loop, if we find any number that is prime, then we push it again to the number. And just to print it out, what we do is echo $I, and I would like to have a BR over here. Let's see if this prints out our prime number set. So maths.test, so this is prime 4, and we can see 3 5 7 11 97. That's all. That's correct. Now let us see, two semicolons. Let us calculate the number of loops we went through. So let us set a counter to be 0, and in each loop I would like to increase the counter by 1. Let's see how many loops we went through. I haven't printed out the counter, so let me just echo counter, or number of loops is $counter. So let's see how many loops we ran through. Only 317. In the first we had 4,950 loops, in the second we had 2,450 loops, in third we had 933 loops, and now we only have 317 loops. So we can see that our code is getting better and better and better, and there are more ways of making the result of prime numbers better, which we'll be discussing on later videos, maybe after couple of videos, like maybe 13 14 videos. We have some more stuffs to discuss in this series of logic building. So we have covered 4 ways of printing out prime numbers, and I'm sure that we'll be dealing with more in future, and those will be more interesting because it will be dealing with some theories of math, which sounds a bit like say complex, but that will make our code more efficient, which I don't want to discuss right now. So stay tuned to see more videos like this, and if you like the videos, don't forget to like and subscribe and share the video with your friends. I hope you like the video. Thank you.